Okay, so starting topic 7. Topic 7 is slope-intercept form and parallel and perpendicular lines. So the concepts we're going to go over today are slope-intercept form, so that y equals mx plus b. So we talked about that a little bit in the past couple notes. Finding the slope from 2 points. So if I'm giving you 2 points, how to find the slope from that. Identifying the slope and the y-intercept mathematically. Using the slope-intercept method to graph, and then finding parallel and perpendicular lines. This topic's a bit longer. So the first concept, slope-intercept form, that y equals mx plus b. We know that m is our slope, and our slope could be written as rise over run. And then the b is our y-intercept. Remember, our y-intercept is always written as 0, comma, and then the number. And again, it just mentions what I just said. So this is called the slope-intercept form because it's the easiest way to find both the slope and y-intercept. The slope m of a line contains 2 points, x1, y1, x2, y2. So these are just random points here. And they're labeling them with 1 and 2 so we can tell the difference between the first point and the second point. We can write the slope as the following. So slope m can be written as rise over run. We use this rise over run when we're graphing. So this one is used for when we're graphing. Bless you. Then we have change in y over change in x. This is used when we're doing applications. So all of this means the same thing, we just use them in different scenarios. And then lastly, we have the formula y2 minus y1 over x2 minus x1. That's how we find the slope mathematically. Okay. So all of these all mean the slope. They all are equal to m. Just in different cases, we'll use a different quote-unquote formula. So the first examples we're going to go through is we're going to be using that rise over run to find the slope on graphs. Okay. So looking at the first example, before we can find the slope, we're going to have to find 2 perfect points. And what I mean by perfect points is that it is a point where our graph crosses this grid at a corner. So for example, this point right here crosses the grid at a corner. So right here, if we consider this our square, that point is right there at the corner. So that is called a perfect point. Okay. Would this point be considered a perfect point? No, because it's not in a corner. Okay, so we couldn't use that one. So not that one. What about this one? No. Good. So it has to be in that perfect corner. So a good one to use would be this one. Because looking at our grid, it's in a perfect corner. Okay. So what we're going to do here to find the slope using rise over run is we're going to take these 2 points, so the ones that I have in red, and I am going to see how far up this point goes. So for example, this goes 1, 2, 3, 4 up. Up is positive on the y, so I'm going to write a positive 4. And then in order to meet my other point, I'm going to run 1, 2, 3. And again, we're going in the right direction, so this is a positive 3. So if I was to write my rise over run, my slope would be 4 over 3. If we ever get a fraction that can be reduced, we would reduce that, and that would still give us the slope, just in a reduced form. 4/3 cannot be reduced, so this would be our slope. Yes?
Can there be multiple points on the line that actually cross through the corners, so that answer change depending on which 2 points we take?
Correct. So you could choose different points. Your answer won't change. You'll just end up with a larger fraction that you'll have to simplify. So you could have chose a different point and ended up with 8/6. That would still reduce to 4/3. Yes, there's lots of points on the graph that we could use, as long as they are landing on a corner. Okay. Let's go to look at number 2. So again, we're picking any points on this graph as long as it's on a corner. So we have this point right here and this one down here. And again, there could be several others. These are just the first ones I see. Okay, so we have our 2 points. We're always going to do rise over run. So I'm going to start with this bottom point here, and I'm going to rise 1, 2, 3, 4, 5 to meet my other point. Since I'm going up 5, that's a positive 5. What would happen if I had to go down 5? Negative 5. Okay, and then now I'm running 1, 2, 3 in the left direction. So is that going to be a positive 3 or a negative 3? Negative 3. So if I write my rise over run, I had to go up 5 and left 3, giving me the slope negative 5/3. Because technically I should have wrote the negative on the outside, but it's fine. 5 over negative 3. Okay. You don't always have to rise up. I could have started with this top point, and then I could have gone down. So looking at it from a different direction, I could have gone down 1, 2, 3, 4, 5, which is a negative 5. And then to the right, 3. 1, 2, 3, which is a positive 3. But when I write my rise over run, I'm still going to get a negative 5/3, like I did in my original answer. Okay, so no matter which direction you choose, you're going to get the same answer. Okay. Okay, at number 3, right away, we've seen this line before, and we already know the slope without finding a rise over run. What is the slope?
No slope.
There's no slope, so we would write slope as m equals 0. Okay. Here, our slope is equal to 0 because we have that horizontal line. We could try doing the rise over run method. And let's say we use these 2 points here. We can't rise anywhere. We can't go up to meet the point. We can only run. So our rise would be 0 and our run would be 1. 0 divided by any number is 0. So 2 ways. If you can't remember that a horizontal line gives you a 0 slope, then you can still do rise over run and you'll still get that 0. Okay. Okay, go ahead and take a moment to do number 4. And then we'll do it together. So this is one that there are plenty of points on the graph that you could use that have those perfect corners. You're always double checking to see if you can reduce your fraction. Okay. I'm going to go ahead and use these two corners. So I have a perfect corner here and a perfect corner down here. Okay, so doing my rise over run, I have to go up 1, 2, 3, 4. Okay, and then I have to go to the right 1, 2, 3, 4, 5, 6, 7, 8. Okay, going in the right direction, so it's a positive 8. I went up, so it's a positive 4. So my rise over run is going to be 4 over 8, which I know reduces to 1/2. So you should have got 1/2 as your slope. Okay. And we could have found that quicker by using these points here. Right? Because those are the perfect corners that are closer together. Okay, number 5, what do we know about a vertical line?
Undefined slope.
Good, the slope is undefined. So the slope here is undefined. Okay, which we know because this is a vertical line. But if we want to use the rise over run method, we can. So let's use these 2 points here. So for the rise over run, we're able to rise 2, but we're not able to run anywhere. So that means we have the fraction 2 over 0, and does that exist? No, 2 over 0 does not exist. So that's how we know that the slope is undefined. Does not exist, or shorthand DNE. Again, if you see the questions like number 5 and number 3 on an exam, and you don't need to show a whole bunch of work there. If you can tell me that, for example, 5 has an undefined slope because it's a vertical line, that's enough work. Okay, you don't have to do the whole rise over run part. Okay, last one for this example is number 6. Go ahead and take a moment and do number 6. So this one is one that does not have too many perfect corners here. And be careful with this one right here. This is not a perfect corner right there. Because if I was to zoom in, it doesn't hit the corner exactly. So I'm going to go ahead and use this corner and this one, because I know for sure those are crossing through the corner of that grid. So doing my rise over run, I'm going to go up 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to run in the left direction, which is going to make my number what? Negative. 1, 2, 3, 4, 5. So my slope is what? Good. 8 over negative 5. I'm just going to put that negative in the front. So negative 8/5. Okay. So that's how we find slope from graphs. We use that rise over run formula. Okay. In the next example, we do not have graphs. We have points. So when given 2 points, you have to use the slope formula. The slope formula, as mentioned above, is m is equal to y2 minus y1 over x2 minus x1.
You said when given 2 points, you use what? I'm sorry? Oh, slope formula.
Yes, slope formula. Okay. Notice that my points are not labeled. I'm going to have to do that myself. So labeling my first point is x1, y1, and my next point x2, y2. Let me... Okay. So now that I have my formula and my points labeled, I'm just going to plug in those numbers into my formula. So I know that y2 is negative 3 minus y1, which is negative 2. Notice how I'm putting that negative 2 in parentheses. That's because I don't want to get it confused with the negative in front of it. Okay, so right there I have minus a negative. Over x2, which is 8, minus x1, which is 6. So this is me setting up my slope in the formula. We know that minus a negative is the same as saying plus a positive. So I have negative 3 plus 2, which is negative 1, and 8 minus 6, which is 2, meaning my slope is negative 1/2. The important part here to remember is that these negatives, these minus signs, are part of our formula. Okay? So if you have to bring down a negative number and put it in the formula, it's always safe to put that negative number in parentheses. Okay? Let's look at number 8. So again, I have my formula, y2 minus y1 over x2 minus x1. I'm going to label my points. My first point is always x1, y1, and my second point, x2, y2. Okay, we are dealing with the fraction in the second point, so that's going to have us have an extra step in there, okay? So plugging everything in, I have y2, which is negative 3 over 8, minus y1, which is negative 3. So I'm going to put negative 3 in parentheses. Over x2, which is negative 2, minus x1, which is 5. So on the top, since we have minus a negative, we know that's the same as plus a positive. But now we have a fraction added to a number, so that means we have to get a common denominator. So that 3 we can write as 3 over 1, meaning the common denominator between these two fractions would be 8. So we would have to just multiply that second fraction by 8 to get a common denominator. So to multiply the top and bottom by 8, okay. This is going to give me 24 over 8. Okay. So now I have negative 3 plus 24, which is 21 over 8, and that's just my numerator. And then simplifying my denominator, negative 2 minus 5 is negative 7. Okay, we can't leave our fraction like that. So how are we going to reduce 21 over 8 divided by negative 7? Good, we're going to divide it. And what are we dividing by? So this negative 7 right here turns into negative 7 over 1. So this is equal to 21 over 8 divided by negative 7 over 1. So when we're dividing two fractions, we're going to multiply by the you guys remember from the beginning? When we're dividing two fractions, we multiply by the reciprocal. What's the reciprocal of negative 7 over 1?
1 over negative 7.
1 over negative 7. So this is equal to 21 over 8 times 1 over negative 7. Now we can multiply our fractions across and we get 21 over negative 56. And this reduces by what number? By 7. So if we divide 21 by 7, we get 3. And then negative 56 divided by 7 is negative 8. Okay. So in these ones, when we're dealing with fractions, we have to remember what we learned in topic 1. And that is the property of fractions, how to add them, how to subtract them, multiply and divide. Okay. So now looking at number 9, go ahead and take a moment and work on number 9. So here's your formula again, y2 minus y1 over x2 minus x1. And then labeling your points. Okay, what'd you guys get? Just go ahead and shout it out. Okay, anyone else get a different answer?
That's 0 over negative 4.
0 over negative 4. Okay, let's plug them in and find out which one's correct. Okay, so plugging in y2, we know y2 is negative 3 minus y1, which is also negative 3. So I'm going to have to put that second negative 3 in parentheses. Over x2, which is 1, minus x1, which is 5. So minus a negative is plus a positive. So negative 3 plus positive 3 is 0, and 1 minus 5 is, okay, which tells us that our slope is 0. All right, because we can reduce 0 over negative 4 to just be 0. So m is equal to 0. And we know that the graph of that looks like what? Vertical or horizontal? Horizontal. So we know the graph of that looks like something like this. So 0 slope. So just make sure we're paying attention to our signs here, and that's what can mess some people up, is the signs. Okay. Number 10, we have a bunch of fractions here. So first I'm going to write my formula, label my points, and start plugging everything in. Okay. So y2 I have as negative 7 over 6 minus y1, which is 5 over 6. x2, which is 5 over 3, minus x1, which is 2 over 3. So at least when we plug all our numbers into the formula, they already have a common denominator. The top one is 6, bottom one is 3. So that means we're just going to simplify these numerators here. So negative 7 minus 5 gives us negative 12 over 6. And then on the denominator, 5 minus 2 gives us 3 over 3.
What did that just make it 1?
Correct. So these fractions do reduce. Negative 12 over 6 gives us negative 2. And 3 over 3 gives us 1. So that means we can say our slope is what number?
Negative.
-2, because we don't need that 1. Okay, any questions so far?
So in this case, it would just be what? Down 2 over 1?
Correct. It'd be down 2 and then to the right 1. Okay, number 11, so we have some fractions to deal with in this one again. So we have our formula. Okay, eventually you won't have to write the formula. You'll have it memorized. Okay, so, oh, and then label my points. Okay, so plugging in y2, we have -4 over 7 minus y1, which is 4 over 5. And then x2, which is 1 over 2, minus x1, which is 1. Okay. So on the top, in order to subtract these two fractions, we need a common denominator. What would that common denominator be?
35.
35. So I'm going to multiply the first fraction by 5, second fraction by 7. Remember, that's the top and the bottom. Okay. So my first fraction, I have -20 over 35. And then in my next fraction, I have 28 over 35. Okay. Technically, for the denominator, I should be getting a common denominator and then subtracting. However, we know that 1/2 minus 1 is what? Someone said it. Negative what? 1/2 minus. Yep, -0.5, or since we're leaving everything in fractions, -1/2. Because we know that 1/2 plus 1/2 is 1. So 1/2 minus 1 is -1/2. Or if you want, again, you could just find the common denominator by multiplying this part by 2. So now simplifying the numerator, we have -20 minus 28, which is what number? -48 over 35 over that -1/2. So we have a fraction divided by another fraction. So that means we're going to multiply by the reciprocal. So we have -48 over 35 multiplied by the reciprocal of -1/2, which is -2 over 1. We just flip that fraction. Now I can multiply across, and -48 times -2 is positive 96, and 35 times 1 is 35. So that's our slope, 96 over 35. Now take a moment and work on number 12. Okay, you want to get an answer?
Undefined?
Good, good. So you should have got -11 over 0, but we know anything divided by 0 is undefined. So plugging in these numbers, y2 is -7 minus y1, which is 4, over x2, which is 1, minus x1, which is also 1. So negative 7 minus 4 is negative 11. 1 minus 1 is 0. So we know that this slope is undefined. We know it's undefined because you can't divide by 0. And then we also know that the graph of this looks like what? Vertical line. Okay. Any questions about finding the slope from 2 points? Okay. Now we're going to be given equations, so linear equations, and we're going to have to turn these equations into slope-intercept form. So I believe that's something we did in the last notes. And then from that, we're going to identify what is the slope and what is the y-intercept. Okay, and that's what that highlighted section says, that in order to find the slope and the y-intercept from a linear equation, we have to make sure that our linear equations are in y equals mx plus b format. So looking at 13, is this in slope-intercept form, yes or no? Are you sure?
No, it's not.
It's not because y is not by itself yet. So in order to get y by itself, we're going to have to do what? Divide by 2. Okay, so if I divide every term by 2, I get y is equal to 3 halves x plus 4. Now this is in y equals mx plus b form. We can clearly see the slope and we can clearly see the y-intercept. So in this case, the slope is what number?
3 over 2.
3 over 2. And our y-intercept is 4, but we always write it as a point, so that's going to be what? 0, 4. Okay, so slope and y-intercept. When being asked for the slope, would you include the x in your answer?
No.
No, so you wouldn't say the slope is 3 over 2x. Okay, because the slope is whatever is in front of the x, just that number. That is one mistake I see a lot on the exam, so I'm just pointing that out. Slope is just a number. We do not include any variables. Okay, number 14, is that in slope-intercept form? No, what form is it in? Standard form. This is in standard form. Remember that ax plus by equals c. But we want to put it into slope-intercept form, so that means we need to get y by itself. So what would be our first step to get y by itself? Subtract 2x. Am I going to combine that with that 15? No, why not?
They don't match.
Good, they're not like terms. Good, they're not like terms. And then what would be our last step to get y by itself? Every term by 3. So we have y is equal to negative 2/3 x plus 5. Now this is in y equals mx plus b form. Okay, so that tells us that our slope m is negative 2/3, and my y-intercept b as a point is 0, 5. Okay, the reason I'm telling you to put it as a point, because eventually in the next examples, we are going to use that point and use that slope to create a graph. Okay, so always write your y-intercept as a point. Okay. Number 15, is that in slope-intercept form? No. Is it in standard form?
No.
No. So we only have one variable here, and that variable is y, so we still have to get it by itself. So what do we have to do? Divide by -3, so we have y is equal to -4. Okay? This is now in that y equals mx plus b form. However, we're missing what?
Your y-intercept.
We're missing our slope. We have our y-intercept.
Oh.
-4 is the y-intercept. Remember, our slope is the number in front of x. So if we don't see x, that means we don't have a slope. So we say that our slope is what? We just don't have it. It could exist, we just don't have it. 0. So we could technically write this as y is equal to 0x minus 4. And that tells us that our slope is 0 and our y-intercept is 0, -4. So if we end up with an equation that only has y, we know that the slope is going to be 0. If only has y, m is going to be 0.
Would that be a horizontal line?
Yes. Yes, the graph would look like a horizontal line. Okay. What if we only had x in our problem instead of y? If we only had x, then we would assume our slope is what? Undefined. So think of the opposite. Here we only had y, so we know the slope was 0. If we only had x in our equation, the slope would be undefined. Okay, 16, is this in slope-intercept form or standard form? Standard form, because I have my x and y on the same side. Okay. Before I turn this into slope-intercept form, I like to get rid of the fractions. Okay, how do we get rid of fractions? You guys remember? We have a linear equation. Multiply the whole thing by what?
By 3?
By 3. Why are we multiplying by 3? The common denominator, okay? So if these numbers on the denominator were different, if we had like a 2 and a 3, we would multiply by the common denominator 6. Okay, it's whatever the common denominator is. So every single term here is going to be multiplied by 3. So I'm going to go ahead and write that out. 1/3 x is going to be multiplied by 3/1. -2y multiplied by 3. I'm just leaving this one as 3 because -2 is a whole number. And then equals to 2/3 times 3/1. Okay. That first fraction of 1/3 times 3/1, notice that if we were to look at the diagonal, these 3's cancel out. So that means we are left with what number in front of x? 1, but I'm not going to write that. I'm just going to write x. -2y times 3 is -6y. And then again, on the diagonal, these 3's cancel out, so we would left with what number? 2. Okay. So now we have a prettier version of the standard form. Okay. We still need to put this into y-intercept form. So what would be my first step?
I'm sorry, ma'am, but
Yeah.
I'm still kind of confused on how you got 2.
So if we look at diagonals when we're multiplying fractions, if the numbers can cancel or reduce, we do that first to simplify. If you don't want to do that, we could still say, okay, 2 times 3 is 6, 3 times 1 is 3, 6 divided by 3 is 2.
Okay.
But since these 3's cancel, we can assume that they are 1. So I did 2 times 1, which is 2, 1 times 1, which is 1, so 2/1. Good. Any other questions? No? Okay. So what steps first to get y by itself?
Add 6 point.
Subtract that.
Subtract x. Remember, we want y by itself. So we have negative 6y is equal to negative x plus 2. Always put your variable in front of your constant. Okay, what would be our last step to get y by itself? Good. Divide everything by negative 6. So we have y is equal to, what does this end up being, that negative x over negative 6? What number would be in front of x?
Negative 1.
So, yes, so we assume there's a 1 there. So positive 1/6x. Okay, remember, we want to separate that number from the x so we can easily find our slope. And then 2 divided by negative 6, negative 3. So this here is our y equals mx plus b form. So now that we have this in the correct form, what is the slope?
1/6.
1/6. And what is the y-intercept as a point?
0,
I made a mistake. Do you,
Yeah,
Yeah.
2
Negative
over negative
1/3.
6.
yeah. Just making sure you guys are awake. Yeah, so it would be 0, comma, negative 1/3. Okay. Okay, go ahead and attempt number 17. First turning it into that y equals mx plus b form, then identifying this slope and the y-intercept. Okay, so first I'm going to turn this into the correct form. So you should have subtracted 6x to the other side and got negative 3y is equal to negative 6x plus 9. Then divide everything by negative 3 and get y is equal to 2x minus 3. Okay. And then from here you can find the slope and the y-intercept. We know that the slope is 2, and the y-intercept as a point is 0, negative 3. Okay. And then last one for this example is number 18. Number 18, we have standard form that includes fractions. So what should we do first to the entire equation? Multiply by what number?
6.
6. And why are we multiplying by 6? Common denominator between 2 and 3 is 6. Okay, so again, I'm going to write out it step by step. So 1/2 x times 6 over 1 minus 2/3 y times 6 over 1 and 4 times 6. Okay, so I don't need to write that 6 as a fraction because it's being multiplied by a whole number. Okay. So if we continue on doing that reducing method by looking at the diagonals, this 6 and this 2 can reduce to 3 and 1. Right, because we could divide both by 2. Same with this 6 and 3. We could divide by 2 and we get 3. Or sorry, divide by 3, get 2 and 1. So when we multiply across, it should be easier for us. So the first one, we have 1 times 3 over 1 times 1, which is just 3x. The second one, we have negative 2 times 2 over 1 times 1, which is negative 4y. And 4 times 6, 24. So now we have standard form without the fractions. So what would be our first step to get y by itself? Subtract 3x. So we have negative 4y is equal to negative 3x plus 24. And then last step,
Divide by negative 4.
divide by negative 4. So we have y is equal to 3/4 x because those negatives cancel out. And then 24 divided by negative 4 is negative 6. Okay, which means we have a slope of 3/4 and a y-intercept of what point? 0, negative 6. And again, getting rid of the fractions in the beginning just makes our problem easier towards the end. You could still go through this whole problem with the fractions intact. I just feel like that's more room for mistakes to happen.
And this was putting an equation into slope-intercept form?
Yes.
Okay.
So this is standard to slope intercept. Okay. Let me see if this is the last topic. No. Okay, the next concept here is we're going to continue doing what we were doing in the last couple examples. But now, once we find our slope and our y-intercept, we're going to use that to create our graph. Okay, so we're doing the same concept of getting this into slope-intercept form, and then we're going to use that information to graph. So on 19, we're turning this first into that y-intercept form, slope-intercept form. So our first step would be to do what? Good, subtract 5x. So I get 2y is equal to negative 5x plus 10. And then last step, divide by 2 every term. So I get y is equal to negative 5 over 2x plus 5. So that means this negative 5 over 2 is our slope, which since we're graphing is written as rise over run. And then this 5 is our y-intercept written as the point 0,5. Okay. When we have this information, the first thing we need to do is plot the point. Okay, so our point is 0,5. Okay. Then in order to find our next point, we're going to have to use that slope, that rise over run. So since it's negative 5 over 2, are we going to go up 5 or down 5? Down 5. Okay. Now we're going to go which direction to?
Does the negative take over the whole fraction?
In this case, we're just going to give the negative to, I usually just give it to the numerator.
Okay, so that's
Because if we gave it to both, we would have a negative over a negative, which cancels to a positive. So you can give it to either one. I usually just give it to the numerator. Okay, so the 2, are we going to go in the left or the right direction? Right, because it's positive. So that means our next point is right here. Once we have 2 points, we can connect them and create our graph. So that means the graph of 5x plus 2y equals 10 looks like this. But yeah, that's a great point. Let me write that. give negative to the numerator. Numerator. Okay. Okay, so on number 20, before we can start, we're going to get rid of those fractions. So what are we going to multiply everything by? Good, 8, because that is the common denominator. Okay, so again, writing this out. 1/4 y times a over 1 minus 1/2 x times a over 1 equals 1/2 times a over 1. So every term is being multiplied by 8. Okay. On the diagonal on the first fraction, this 8 and this 4 can cancel to a 2 and a 1 if we divide both by 4. On the next fraction, these 8 cancels out completely, and I'm left with just 1 in their place. Okay. What about this last one? On the diagonal, we have an 8 and a 2, so that's going to reduce to what? A 4 and a 1. So now if I multiply across, I get 2y minus x equals 4. Okay. We still need to get y by itself, so what am I going to do?
Divide by 2.
Not yet.
Oh, we got
Add x. So I get 2y is equal to x plus 4. Now I divide by 2. So what number is in front of that x if when I simplify?
1.
A 1. So I have 1x over 2. So what number can I bring in front of the x? I know a 1's going to be on top. What's going to be on bottom? 2. So I'm bringing out a 1/2. Just remember, we have to detach that number from the x. So 1/2 x is the same as saying x divided by 2. And then plus 2. So that means our slope is what number? 1/2. And our y-intercept as a point? 0, 2. And what do I plot first, the slope or the y-intercept? The y-intercept, so 0, 2. In my slope, 1 over 2 is telling me to do what first? It's rise over run, so what direction am I going first? Up 1. And then that 2 is telling me to go in what direction? To the right. Okay, and then once I have 2 points, I can create my graph. Okay, any questions on 19 or 20? Excuse me. Okay, number 21, we have a fraction in there. So in order to get rid of that fraction, I'm going to multiply everything by 4. Perfect. Okay, so that means I have 2y times 4 plus 1/4 x times 4 over 1 equals negative 2 times 4. Simplifying that, I have 8y plus x, because these 4's cancel out, is equal to negative 8. Okay. First step to get y by itself is to move what? X, so subtract x. And I get 8y is equal to negative x minus 8. And then divide everything by 8. I get y is equal to what? Someone said it a little louder.
Negative 1x over 8.
And we got to remove that x, though, out of the way. So not negative 1x over 8, but negative
1/8.
1 over 8x, right? We got to move that x out of that number because we need that number to find our rise over run. And then minus 1. So that means this is my slope, and this gives me the point 0, negative 1. Okay, and what am I going to do first?
Plot the y-intercept.
Good, plot my point, that's 0, negative 1. And what is that negative 1/8 telling us to do?
Down 1/8.
Good, down 1, because it's a negative 1. In which way 8? To the right, because it's a positive 8. And that gives me our next point. Once I have my 2 points, I can connect them to create my line. Okay. Pretend that crosses through the other dot. As long as you have that work on there, that rise over run, all those, and I see that you know where this graph goes, this class doesn't require a ruler, so I'm not expecting your lines to be perfect. Okay?
Curiosity question.
Yes.
If we always apply the negative to the numerator on a rise over run, will we ever end up with a negative on the run part, so it goes to the left?
Correct. We won't ever.
Well, okay.
But you could assign the negative to the denominator. Just keep it consistent. Assign it to one of them. So if you're always going to assign it to the numerator, do that. Or if you're always going to assign it to the denominator, do that. You're going to get the same graph. Just your rise over run points are going to go in a different direction. But you'll still get the same line. But yeah, that's a good point. Assign the negative to whatever you feel comfortable doing. Just keep that consistent. Okay, number 22, we need to get y by itself. So what are we going to do first? Good, add 2x. So I get 12y is equal to 2x plus 6. Last step. Divide everything by 12. So I get y is equal to what? One over 6 x. Remember, the x is separate from that number. Plus 1/2. Okay, so that means my slope is that 1 over 6. And my point just consists of a fraction this time. So 0, 1/2. Which we know is the same as saying 0.5. Okay. So graphing that point, 0, 1/2. Going to zoom into my graph here. It's going to be right here. Notice now, since that point is in the middle of a grid, when I do my rise over run, I have to make sure that I stay consistent and keep that rise over run in the middle of the grids. So, for example, we know our slope is 1, 6. So I'm going to go up 1. And notice going up 1 makes me still in the middle of that next grid. Okay? And then I'm going which direction? 6. To the right. So staying in the middle of the grid, 1, 2, 3, 4, 5, 6. Okay.
Now, question, would you take 0.5 as the answer for the y-intercept
Yes.
as opposed to 1 over 2?
Yes. Both would be correct. If you put 1/2 or if you put 0.5, that's both correct.
What it would be is like in a different fraction, so if you did, say for example, 2/3, would you then convert that to a decimal and still plot that?
Correct. Correct. Anytime you have to plot something, if you don't know what that fraction is, turn it to a decimal. That's still going to be the correct answer. because it's easier to plot 0.3 than it is to plot 1/3.
And you
example.
did say previously in the last class that you would accept it as an estimate on the graph, correct?
Correct.
So then-
Yeah, I'm not going to zoom into your guys' graph and be like, well, this is not exactly in the middle. Minus 5 points. I don't have time for that. I got kids at home. Okay. Number 23. In this case, we only have what variable? Y. So right away, we know our slope is what? Someone said it a little louder. 0. Okay. And we know our graph is going to look like what type of line? Horizontal. Okay, I keep that information in the back of my head. Okay. Then I go ahead and solve my problem. So 5y divided by 2 equals 10. We need to get y by itself, so I'm going to do what?
Multiply by 2.
Multiply both sides by 2. So both sides by 2. And I get 5y is equal to 20. When I multiply by 2 on the left side, these 2's cancel, okay? That's why we're just left with the numerator. And then last step, divide by 5, and I get y is equal to 4. That 4 tells us what? The y-intercept, which is at what point? 0, 4. So if I was to graph this at 0, 4, and we know it's a horizontal line, I don't need my other point there, and I am going to just draw my horizontal line. In these problems, if they're asking for the slope, I would need this information, slope equals 0. If it's not asking for it and just telling you to use this information in graph, then I am only going to be looking at the graph.
But if it was asking for the slope, would we just write it as 0?
Yes. Or you could go from this step here and say, okay, y equals 4, or that's the same as saying y equals 0x plus 4. 0 is our slope. Either way. Okay, number 24, we only have the variable x. So that tells us what about our slope?
It's undefined.
Undefined. Okay, undefined. And we know that graph looks like what? Vertical. Okay, I'm still going to solve for that variable. So in order to get x by itself, I'm going to do what? Divide by 8. So I get x is equal to -2. When I had y equals to a number, that gave me my y-intercept. What happens when I have x equal to a number? That gives me which intercept? The x. So that means this point can be written as -2, 0. So I need to plot that point. And we know it's a vertical line, so I'm just going to draw a vertical line through that point. For number 23 and number 24, there is no way to know really the information of if it's horizontal or vertical unless you just know that concept, okay? You couldn't figure that out mathematically unless you know that if you have a 0 slope, it's horizontal. If you have an undefined slope, it's vertical. So that's something definitely to memorize if you haven't already. Okay. I'm going to go ahead and just